Introduction. Hey kids, what are you doing?
We are playing carom board.
Wow, that's great. Can I ask you something?
Sure, Dad.
Do you know which motion is occurring in this game?
Yes, motion in a straight line.
Objectives. At the end of this lesson, you will be able to define scalars and vectors, calculate multiplication of vectors, calculate addition and subtraction of vectors, understand resolution of vectors, define motion in a plane, define motion in a plane with constant acceleration, understand relative velocity, understand projectile motion, understand uniform circular motion. Definition. Motion of an object in two dimensions is known as motion in a plane. In our daily life, we can see many activities in which motion is done in two dimensions. For example, an object fired into the air moves in a vertical two-dimensional plane. Scalars and vectors. In physics, quantities are classified in two categories. They are A. Scalar and B. Vector. Scalar. The quantities which can be specified completely by their magnitude alone. For example, work, energy, power, charge, etc. Vector. The quantities which can be specified completely by their magnitude and direction. For example, displacement, velocity, acceleration, force. The geometric representation of a vector is done by an arrow. Position vector represents the position of a particle with respect to any other point. Displacement vector represents the displacement of the particle between 2 points. Multiplication of vectors. When a vector A is multiplied by a number say n, we obtain a vector V given by V vector is equal to n into A vector. Let's take an example. If a vector A is multiplied by 2, the resultant vector 2A vector is in the same direction as A vector and has a magnitude twice of A vector. Addition and subtraction of vector. Vector addition is done with the help of three laws. A. Triangle law. The sum of the vector A and vector B is R vector is equal to A vector plus B vector. B. Parallelogram law. If two vectors are represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant is given by the diagonal passing through the common corner. C. Polygon law. If a number of vectors acting at a point are represented by the sides of a polygon taken in cyclic order, then the closing side of the polygon taken in the opposite order represents their resultant. Subtraction of vectors. The process of subtraction can be seen as addition with negative sign given by. Resolution of vectors. The term resolution means breaking up into component parts. The process of resolution is opposite to vector addition. Now, what are the components? If a vector is resolved into several vectors whose combined effect is the same as that of the given vector, then the resolved vector are called the components of the given vector. Motion in a plane. Let's see motion in two dimensions using vectors, position vector and displacement. The position vector R of a particle P located in a plane with reference to the origin of an XY reference frame is given by R is equal to XI double dash plus YJ double dash. A particle moves along the curve and is at P at time t and P dash at time t dash. Then the displacement is delta R is equal to R dash minus R. By putting values, we get delta R is equal to I double dash delta X plus J double dash delta Y. In one dimension, the velocity and the acceleration of an object are always along the same straight line. However, for motion in 2 or 3 dimensions, velocity and acceleration vectors may have any angle between 0 degree and 180 degree between them. Motion in a plane with constant acceleration. Let us take an example to understand. An object is moving in XY plane and its acceleration a is constant. Now, let the velocity of the object be nu naught at time t is equal to 0 and nu at time t. Nu is equal to nu naught plus at. This is the equation in component form. We conclude that motion in a plane can be treated as 2 separate simultaneous one-dimensional motions with constant acceleration along 2 perpendicular directions. These results are also valid for 3-dimensional motion. Relative velocity. The velocity of the object with respect to the observer is obtained directly by subtracting the velocity of the observer from the velocity of the object. Velocities are represented by vectors and they are subtracted by vector method. Projectile motion. An object thrown into space with some initial velocity and then allowed to travel freely under gravity is called a projectile. For example, a bomb dropped from an aeroplane. A cricket ball hit by a batsman. Motion of an object projected with velocity nu naught and angle theta naught is shown in figure. The path of a projectile is a parabola. Time of flight of projectile is Tf is equal to 2 nu naught sin theta naught divided by g. Maximum height of a projectile is Hm is equal to nu naught sin theta naught square divided by 2g. The horizontal distance travelled by a projectile from its initial position to the position where it passes y is equal to 0 during its fall is called the horizontal range. Horizontal range of projectile is given by product of nu naught square and sin 2 theta naught divided by g. Example. Let's take an example of projectile motion. A projectile has a range of 50 meter and reaches a maximum height of 10 meter. What is the elevation of the projectile? Let's see the solution. We know that horizontal range is equal to product of nu square and sin 2 theta divided by g. We derive the relation between height and range is given by h upon r is equal to 1 by 4 tan theta. On calculating this equation, we get the value of theta equals to 38.66 degree. Uniform circular motion. The revolution of an artificial satellite in a circular orbit around the Earth is an example of circular motion. The time taken by the particle to go round the circle once is called the time period of the particle. The number of revolutions made by the particle in 1 second is called the frequency of revolution of the particle. When a particle moves with constant speed in a circle, the velocity is always tangential and has an acceleration which is directed radially inwards. Both velocities and accelerations have constant magnitudes but changing directions. Did you know? The trajectory is a conic section like an ellipse or a parabola. This agrees with the observed orbits of planets and comets to a reasonably good approximation. Although, if a comet passes close to the Sun, Then it is also influenced by other forces such as the solar wind and radiation pressure. The kinematic equations for uniform acceleration do not apply to the case of uniform circular motion. The resultant acceleration of an object in circular motion is towards the center only if the speed is constant. Summary. Let us summarize what we have learned. Scalar quantities are quantities with magnitudes only. Vector quantities are quantities with magnitude and direction both. When a vector A is multiplied by a number say n, we obtain a vector v given by v vector is equal to n into a vector. The process of subtraction can be seen as addition with negative sign. If a vector is resolved into several vectors whose combined effect is same as that of the given vector, then the resolved vector are called the components of the given vector. For motion in 2 or 3 dimensions, velocity and acceleration vectors may have angle between 0 degree and 180 degree between them. An object thrown into space with some initial velocity and then allowed to travel freely under gravity is called a projectile. When a particle moves with constant speed in a circle, the velocity is always tangential and has an acceleration which is directed radially inwards.